Okay, here we are back. We're trying to finish up this problem on the inverse function of this particular f. What we saw here was that at the bottom of the page, the inverse function that we found, f of x, is not 1-to-1. So this function right here, it's not 1-to-1. It is going to need a domain restriction, and we're working on that. In class, we had verified the inverses, and I'll do that here just to make sure that the work you had on your paper is correct. So we put the function f into f inverse, and that is going to give us 2x minus 3 squared plus 3 over 2. I'll square and get 2x minus 3 plus 3 over 2. Little extend page here. So that 2x over 2 equals x. And that's what we wanted to have happen. So here we're showing that f inverse undoes f. The other composition, f of x squared plus 3 over 2, would become the square root of x squared plus 3 over 2. Well, I should have a times 2 in front of it. Minus 3 gives us the square root of x squared plus 3 minus 3, and the square root of x squared, which equals x. So we have that they undo each other. More of the problem is going to be these domains and ranges. For the function f, the square root of 2x minus 3, hopefully you're looking at your paper, so that means the expression 2x minus 3 must be greater than or equal to 0. So x is greater than or equal to 3/2. So that is going to be the domain there, so from 3/2 to infinity. The range of f, it's a square root function. We can only take the square root of positive numbers. The square root of a positive number is a positive, except for 0, and the square root of 0 is 0. So that means that my range, the only answers, the only outputs I can get are going to be 0 and positives. Now, as far as the inverse function goes, that was the quadratic function. Quadratic functions have graphs that are parabolas. They are polynomials. So they have domains of all real numbers. Now, in class, Adam had said that he had rewritten his as 1/2 x squared plus 3/2. And doing that might help us recognize the transformations, that this is a quadratic function with a vertical shrink by a factor of half and shifted up 3/2 unit. And that really has a play on the domain because the vertex moves from 0, 0 up 1.5 units. So at the range of f inverse is going to be from 3/2 to infinity. Now, remember what we need. We need the domain of the original function to be equal to the range of the inverse function, and we have that. We also need the range of the inverse function to be equal to, oops, I messed, I went too far, to the domain of the inverse function. And they're not equal, so that's troublesome for us. The good news is that since we wrote this inverse function, we wrote it, we created it, we can restrict it if we want. So all I need to do is cross that out and rewrite it so that it matches what I want it to be. And now if I think about that, if I take half of a parabola, it will match the reflection of the square root function. So now for my final answer, I just need to go back 2 slides and fill in that domain restriction. X is an element of the closed interval from 0 to infinity. So to answer the question, what is the inverse of f of x, I have to give this entire statement, the function f inverse, with that domain restriction makes up the inverse function. So we just needed a couple minutes to finish that up for that solution there, and you should be fine doing the homework now. And we'll answer any questions in class tomorrow. Thanks.